Welcome to part 2 of Basic Compression using HoloEdit 2020.4. This video will cover stabilization. Stabilization is a process that takes a volumetric video clip made up of disconnected meshes and textures and converts it into a series of segments of varying lengths. Within each segment, a single frame's topology is shared for every frame, deformed into the different poses required for each frame. Because of this consistent topology, stabilized segments provide the opportunity for faster editing and effective compression. In HoloEdit, the source frame deformed to create a segment is called a keyframe. A single keyframe can only be deformed to a limited range of poses successfully before it's not possible to generate a good-looking mesh. So with all techniques, segments vary in length based around the best fit for the volumetric performance. The stabilized mesh process tries to build the largest segments possible, but segments can only be so many frames long before the actor or their costume has moved too extremely to be captured with a shared topology. It's important to understand that while each frame in a segment has a consistent topology, each frame is still a different mesh. For most tracks, stabilization is introduced one of two ways: via the load asset stage, where the loaded clip contains data already stabilized beforehand in HoloEdit or an external solution, or via the stabilized stage, introducing stabilization to an unstabilized clip. Let's start by adding a stabilized stage to our track. In the track containing our unstabilized clip, we can select the plus icon to add a stage and select the stabilized mesh stage. Next, we need to add an interval to our stabilized stage. We can do that by clicking and dragging in the track view to select a range of time, and right-clicking to select Add Interval. Alternatively, you can right-click in an empty space on the stage above and select Propagate Intervals. This will create the intervals from the selected stage onto the stage directly following it. It's a great way to quickly create consistent intervals, especially in more complex compositions where you might have several intervals per stage. Intervals can be adjusted by dragging the interval handle to the left and right of the interval, or by clicking and dragging the entire interval to reposition it. After adding a stage and intervals, processing doesn't begin until the stage is executed, which sends work to the server. Stages have various settings that can be configured before executing them. We can select the stabilized mesh stage or its interval to view and edit the stage parameters in the inspector panel. Stabilized mesh is a complex stage with many settings. One setting of note is the max work unit length setting at the bottom of the list. This setting dispatches chunks of this work unit's length to the processing server independently, in linear order. An example, the first 1 to 25 frames, then frames 26 to 50, and so on. This allows faster processing, as each chunk can be processed in parallel. But segments can't extend across the border between two work units. If you have a lot of time for processing, and your clip has very little motion, a higher value might be desirable. But typically, 25 is a good fit. If we had multiple intervals in the stage, we could select the intervals directly to adjust the processing parameters independently. For this clip, we'll use this and all of the other settings at their default values. For more in-depth information on configuring the stabilized mesh stage, see the written documentation on the stabilized stage or a tutorial series on advanced compression, which are linked in the video description. Next, we're ready to begin processing our track. This can be done by either right-clicking on a single interval and selecting Execute, or by right-clicking in the empty space under your stages and selecting Execute All Interval. We'll right-click on our stabilized mesh stages interval and select Execute. You can track how work on the Holographic Processing Service, or HPS, is processing by opening the Job Viewer, which is found under Tools in HoloEdit's top menu bar. From there, you can keep an eye on the information, like current compute time, see how individual work units are processing, or check for processing errors in the console output window. Once the HPS has completed processing work on an interval, its results will be imported back into your composition. HoloEdit will detect when a work item has finished, pause briefly to fetch the job results and apply them to the corresponding interval. It will take a few minutes for this job to complete. We'll come back once the processing has finished. Our job has finished and returned results, and displays a green result status bar below the interval. Our stabilized mesh interval will now display the individual stabilized segments, indicated by the light gray brackets present around each segment. Inside of each segment, there's a diamond marking a frame. This marker designates a frame as the keyframe or pose frame. Each keyframe is identical to the corresponding frame in the mesh source stage, in this case, the load asset stage. This frame was deformed to create the other frames in its segment, which share the same topology. Because volumetric video captures can sometimes vary significantly from frame to frame, the frame chosen as the keyframe may have an impact on the quality of the results. We'll take a closer look at this as we review the clip. We can play back our composition to see our new stabilized mesh sequence. The most noticeable difference is the mismatching textures. Since our meshes have been replaced by one consistent topology per segment, textures no longer match the UV layout. We'll need to generate new textures for our stabilized geometry. We'll address this with a texture transfer stage. But first, let's use HoloEdit's comparison tools to take a closer look and review what changes have been made to the mesh after applying stabilization. Start by selecting the Load Asset stage from the Composition panel, then shift-click on the Stabilized Mesh stage from the Composition panel. Then press the Compare button that appears at the top of the viewport panel to enter the comparison mode. We'll choose the Heat Map mode from the Comparison Settings drop-down above the viewport. And over in the Heat Map Options panel that appears, we'll set the max error to 0.02. Any variation in our mesh between the stabilize and load asset stages that is equal to or greater than 0.02 units will display as red in the heat map. Because our clip was originally exported at a real-world scale of 1 unit equals 1 meter, the distance is about 2 centimeters. Let's scrub through and check out our results. We can see that our results are quite good and are almost completely within the error range. The one exception is a few points where the results of the hands exceed the error max. Because the shape of the hand varies significantly from frame to frame, the hand from our keyframe can't perfectly fit the source data. The segment containing frames 83 to 99 has some pretty obvious issues. We'll add another stabilization stage to address the segment and make some minor adjustments to the new stage parameters to achieve better results. But first, let's continue our review. With the review completed, it looks like we should add a second stabilization stage to tweak the results of the hand. The stabilized mesh and template match stages will ignore preceding stabilization or template match stages, instead referencing the first load asset or clean mesh stage above them. We'll create an interval on our new stabilized mesh stage for frames 83 to 99 and select the new interval in the timeline. To make adjustments to the stabilization parameters in the inspector window, we want a little bit less independent movement in the fingers, so we'll adjust the sample radius so larger clusters of the mesh are deformed together. We'll increase this value to 16 and execute the interval. Let's jump ahead to when the results have returned for this interval. Since we can see that stabilization has given us nice, consistent results that preserve the detail of the original data, we'll go ahead and save the composition as basic compression stabilized. Next, we'll add a texture transfer stage to generate the textures. Unlike most stages, the texture transfer stage requires a reference to another stage in order to execute. This stage takes a texture source stage parameter, which specifies a source mesh and texture stream to sample texture data from. When the texture transfer stage is executed, HoloEdit will compare the source mesh and the current mesh stream and transfer the texture data from the source stage into a new texture stream. We can set the stage parameters by selecting the texture transfer stage from the composition window. With the texture transfer stage selected, click and drag the load asset stage that contains the original texture data stream into the texture source stage parameter in the inspector. Because we know that there are very minimal surface changes from the original mesh data from the load asset stage to the stabilized mesh data, we can leave the auto cage extrusion parameter enabled. The auto cage extrusion will set the cage extrusion difference from the original texture source to the updated mesh automatically per frame based on the highest error between the two mesh. We can select the interval in this stage, right-click, and select Execute. This stage will take a few minutes to complete. When it's finished, we should have a final stabilized result. We'll come back in the next video and we'll apply SSDR to our track for additional compression, and then export our clip in the OMS format for playback. Thank you for watching!